started. So, first time I tried this format, so to say, never streamed before, and I thought this was kind of a good occasion to try it. So, wiremock is a library I maintain. It's a Rust crate, and you can use wiremock to perform tests for applications that have HTTP dependencies. So you have, for example, your API, you call an endpoint, and then the API does some computation and calls other endpoints in other services, either yours or maintained by a third party. And what we want to do is we want to be able to do black box testing. So we want to be able to interact with our API from the outside, which means we need to be able to mock the behavior of the dependencies without actually touching our code. And one of the ways to do it is to intercept the requests that are going out. So adding an HTTP server, which we manipulate in the test suite. And when that HTTP server receives certain requests, we instruct it to respond with a certain type of response template. Looking at an example probably makes this much clearer. So in this async function, imagine this is a test. Well, it's basically a test. You start a mock server. So the mock server is the #1 interface for wiremock. This launches a mock server in a background thread, and it gets a random port from the operating system. At that point, what we do is we create a mock. So we tell the mock server, so we're mounting this here, when you receive a GET request and the path of the GET request is /hello, you must respond with a 200. That's pretty much the behavior we want. At that point, after we call the mount and we waited the mount function, the mock server knows that it needs to respond that way. So if we go and do a GET request to the URL of the mock server, which we retrieve via URI, the status that we get back is indeed the 200. So what we instructed the mock server to do. If, for example, we make any request which is not instead covered by a mock, so for which we're not specifying the behavior, then we'll get a 404. And this is analogous to what you would have if you were interacting with a normal API. So if you're trying a route which doesn't exist, you receive a 404 not found. And this pretty much is wiremock. Like there's a bunch of different matchers, so you can match on method, on path, you can match on query parameters, you can match on certain characteristics of the body, for example, and you can return more elaborate response templates. So status codes, query parameters, bodies, headers, and so on and so forth. And this works decently. I mean, we've been using this, for example, in my day job for half a year now, so to say, and yeah, it covers more or less everything we need. But, there's a but, sometimes it's not the most intuitive to understand why the test is failing. So another thing that you can do with wiremock, let's look at another example. So let's pick one of the tests, one of the mocks tests. Perfect. Here, what you can do is you can set expectations. So you can tell the mock server not only to respond in a certain way, but you can also tell it to check, once it's going out of scope, that a certain mock has been invoked a certain number of times. In this test, for example, we are creating a mock server, and we're telling the mock server to respond with a 200 if it receives a GET request. And we're also telling the mock server that it should expect at least one GET request. If it doesn't, then when it goes out of scope, it should panic. Actually, this is actually a better test. This one's testing something else. And you see this should panic. We can check this really quickly if we run the test. So if we do a cargo test, name of the test. Yeah, that works because we expect it to panic. So let's remove the should panic. And we should get, yes, exactly this. So thread, name of the test, panicked at the fact that the verifications failed. So we said expect 1, and then it says I was expecting one incoming request, one or more, so x major equal 1, but I actually received 0 incoming requests that matched the expectations. In this case, it's fairly obvious that there's no request. But in a more complex scenario, what you're doing is you're spinning up an application, you're making a request to the application, and then you expect the application to make requests to the mock server. And maybe the application is not doing what you want, so it doesn't do the request you expect. But unless you have logs or you're printing certain stuff to stand it out, it might not be obvious to understand why the request did not match. Is it because it didn't do a request? Is it because the request uses a different method? Is it because the request uses a different body? And so on and so forth. So one thing you can do to make things simpler is to implement a functionality that the original wiremock. So wiremock-rs is a port to Rust of a concept that exists in the wider programming community and has been existing for a while. It was the original wiremock is built in Java. You can find it here as all the features you can dream of. And I mostly interacted with it via the .NET port, so wiremock.net. So a feature of the original wiremock is called record and replay. Record and replay means when you're receiving a request, store the request. And then afterwards, if I ask you, tell me all the requests you received. And we received a feature request, 10 days ago, from Alex, a colleague of mine. He's using wiremock. And what he'd like to do, he'd like to be able to get the list of requests received by the server and then do his own assertions afterwards. And that's because of the way he likes to use the library. My angle is slightly different, so it's fine to accommodate this scenario, but my angle is when something fails here, I not only want to know how many requests matched against the mock, I also want to know the list of requests received by the server. So it becomes much more obvious if you're trying to debug to understand, oh, the server was never called, or the server was called, but actually that's not what I was expecting. That's not exactly the parameters that I was expecting the server to be called with. And the other thing is also that allows you to do exploration, especially if you're adding tests to an existing code base, especially if the code base is fairly complex. You often do not know in advance what kind of I/O that code base is going to do. So if you're trying to add test coverage to an existing application, maybe legacy application, well, legacy because it doesn't have tests, so you want to find out what the dependencies of that application are. And what you can do is you can use wiremock to do exploration. So you set up a mock with very, very, liberal matching criteria. So you try to match everything that it's incoming. And then at the end of the test, you get this printout, and you can say, okay, well, the application tried to call this endpoint, and this endpoint. And then you can understand if that is something that you expected and try to understand how the application behaves if you set up different responses for those endpoints. So the LDR, it's a useful thing. You can do a lot of things if you have the capability to record and replay the requests that you have received. So what we want to do is we want to add it to the library. And that's pretty much what we will be doing for probably a couple of hours. I haven't really spec'd out how this is going to work, so we're going to find out together. So I guess the first thing to do would be trying to understand what kind of API we want to drop a flag. What kind of API we want to provide. Even before trying to understand how is it going to work, how will a user interact with it. In this case, if you have an okay, interesting. There's a broken interlink talk. Got to fix that. If you've never worked with Rust before, one of the cool things that you can do using Cargo is actually generate documentation on the fly. So you do Cargo doc, we don't want to build documentation for dependencies, in this case, and then you say open. So you launch as a browser using whatever default browser you have. So in this case, we get the documentation more or less the same as going to appear on docs.rs. So we get a feeling as if we were a user of the library, like what is that going to look like? And it's usually also a way to get a sense if your design makes sense. Like if your docs page looks like a mess and you have tons of struct and it's not really clear what they're doing, then maybe you need to restructure it a little bit. So in this case, we don't have a lot of top level items. It's fairly straightforward. We have a server, we have a mock, we have a builder for the mock, you have a request or response, and a way to specify expectations. And then we have two traits to customize either the way you match an incoming request or the way you respond to an incoming request. Now, recording and replay is conceptually a property of a server, because that's the one thing you're interacting with. So in some way, this needs to live in mock server. Let's look at the way mock server works at the moment. So you have a start method, which is basically a constructor. It's asynchronous because it spins up an instance of a mock server. Start on, in the case you want to specify a port. You want to pass a listener because you already have bound a listener for some reason. This was to accommodate a user who wanted to build a standalone mock server on top of wiremock, but I was fairly innocent. It's also useful sometimes if, once again, you're working with a legacy application and there is some stuff hard-coded that you cannot change, for example, a specific port. So you can make the mock server start on that port without going through the random allocation. Then you have a method to register a mock, which is good. Then you have reset to drop all mounted mocks from an instance. This, for example, is interesting because how should reset interact with recording mocks? When we do reset, should that also forget all the requests that we got so far? Should I keep them? That's a question to answer. Then we have verify, which is a way to, instead of verifying when the mock server gets dropped, verify proactively that all the mocks have been satisfied in terms of expectations. Then you have URI, well, to retrieve the URI of the server, and you have the address. So we retrieve the socket address of the server. Okay. So we probably want a few things. Okay. That's fascinating, actually. So first of all, should recording always be used, or should it be something that you can switch on and off? If you can switch it on and off, then that should be done before the mock server is launched. So you should have some kind of configuration, which at the moment is not really possible because we don't have a builder. Okay, that's a tricky one. For the moment, we can assume that it's always on by default. That's definitely the build we want. So we should probably give the possibility to disable it, especially if somebody is using it for a long-lived type of usage. But the primary use case should always be enabled. Allocating those requests on the memory should not be a problem. Oh, Ethan, nice to see you, at least virtually. Yeah, so let's forget about configuration for now, but let's kind of put that down. But probably I should take some notes. That's something that I usually do on a piece of paper, but in this case, probably more useful to do it in a virtual thing. So notes on wiremock, record and replay. So what have we identified so far? First one is recording going to interact with mock server. Reset. Does it delete the recorded requests as well, or do they stay? That's a question I actually don't have a good answer at the moment. And it's like, we'd like recording to be on by default, but it should be possible to disable recording for long-lived mock server instances, which is the use case, for example, of stop-rs. How do we configure? Do we configure a mock server? Here we have a builder at the moment. So probably with that we might have to introduce a builder pattern of some kind, which probably means we have a break and change in the API, which is not too bad. But yeah, let's keep it in consideration. Okay, I think that's it for now. Let's get started. So definitely we want some kind of method in here to see the requests that have been made so far. That could be called something something. At the moment, let's see, mock server. Yeah, expose mock server is, let me see. Okay, let's chat a little bit about this. So how is this actually working? So the mock server you see in the documentation is actually a facade. So what it is a type that wraps an inner server. And the inner server can be of two kinds. It's either an actual mock server, so it's an actual HTTP server, or it's a server that we are retrieving from a pool of servers. Why do we do this? If you have a lot of tests that you're running concurrently, this test will start and finish continuously. And every time you spin up a mock server, there's a little bit of cost that you need to go through. So you need to open a TCP list, so you need to bind a port, open a TCP listener, start listening for incoming requests, and so on and so forth. We can amortize that a little bit by using a pool. The pool is not necessarily to go faster exclusively, is also to avoid consuming too many sockets. So every time you're starting a mock server, we're acquiring a new port on the operating system. And what that means is that you might violate some operating system constraints. In particular on Linux, the one is gonna get you fairly quickly is your limit. So a maximum limit on the number of file descriptors used by a single process. A test binary is a single process. If you start spawning mock servers, you very quickly surpass the threshold. So by pooling it, we reduce substantially the usage, makes the crate a little bit more friendly. But the idea behind the pool is that it's an optimization. So the user doesn't see it, the user doesn't have to know about it, so everything's private. So you see a mock server and then internally we do different things, depending on what we need, so to say. Which is also an interesting thing, is how does the recording and replay interact with the pooling? That's another question. Record and replay, how does that interact with server pooling? That is often the thing that people overlook when asking for new features in libraries. As new features don't exist in isolation, and actually most of the work is not necessarily implementing the feature, is trying to understand how it fits together with the rest of the existing stuff, either how do they interact, and making sure that conceptually the thing kind of stays, keeps making sense in a way. You don't just bolt it on at the end. Okay, so we have this kind of mock server, and what it does. Oh, why don't you use Vim? Well, JetBrains IDE. I used to use Vim. Well, I'm using Vim bindings, as you can see. But setting up Vim is very laborious, especially if you use multiple programming languages, which is my case. The Rust, bit of C#, bit of Python, and just maintaining my Vim configuration was a full-time job on its own, and IntelliJ works nicely. So I have IDEA Vim, which is the thing I care about the most, and the rest just works. So, where were we? Start on register reset. So let's start like very easily. So let's go with something along the lines of pub function, receive requests. Yeah. Naming is something we can go on again in a second. Okay, so receive requests. And here we start getting a few interesting questions as well. So we expect this to be a vector. So you have 0 or more incoming requests. Now, what do we use to represent the request? There's an internal implementation, but actually it's public. Okay, that's actually much easier. So in the Rust ecosystem, there's 2 crates that generally are used to work with requests and responses on HTTP stuff. So you have the Iberium HTTP crate, first of its kind, so to say, and fairly standardized across the ecosystem. And then there's the HTTP types crate, which is underpinning Tide and a few other projects kind of gravitating around async-std. And HTTP types is very, very nice. Like there's a lot of nicely typed interfaces to a lot of HTTP stuff, which otherwise is a little bit difficult to manage. And we're using HTTP types. And originally we tried to keep this an implementation detail, but then eventually linked to the public API, as it often happens. And especially since when we added the possibility to define custom matchers, so when we added the match trait, which I think it's here, then we had to expose a way to say, okay, work with incoming request. And we defined our own request type. We didn't use the HTTP types request type directly because that's too general. That's like the stuff around streaming the body and performance things. In that, like the nice thing about working on crates for testing is that often you don't care. In particular, we don't have to worry about streaming stuff. So we collect the whole body in a vector of bytes, so it's much, much easier to work with it. So okay, that's actually not a problem. So receive request returns a vector of request. But there we have it. Nicely. So as you see from all the other methods, the way this works is, as we said before, this abstracts on top of a bare server and a pool server. This inner server enum implements the ref. So that means that it automatically behaves as if it was a reference to this type. So as if it was a reference to an actual mock server. So all the methods are self, what is it? Not the constructors, yeah. Self.0, so this is either a pool server or an exposed server. And then the ref magic makes it so that this invokes register on the right stuff. I mean, we could do it by having a match in every single method. This just looks a little bit nicer. So, no problem. So what this means though in practice is that we need to implement these actual methods on the bare mock server, which is not a big deal. But before we start, what we actually want to do is we want to write a test. No, don't commit on main. Let's open a new branch. So this is the following plate. And we want to do add receive request. So I generally adopt squash and merge philosophy. So I use commits mostly as checkpoints, and my commit messages will not be very meaningful. Also because we have loads of commits. And I could then go back and make them pretty, but I generally don't bother. So we want to test. And we can start by doing a log test. So what do we want to do? Mock server, TCP stream, well this is not the best. Let's start from something a little bit more interesting. Yes, like this thing here. self-pressurizing. So we have a mock server, we start it, we set a mock to return 200 here, then we act, and now we reset the server, but that was for that specific test. What we want to do now instead is we want to have the receive requests. So this is mock server dot receive requests. I don't know if this is gonna be asynchronous or not. Let's keep it like this for now. And then we want to make some assertions. I think the first assertion we can make is saying that in this specific scenario we should have a single request incoming, because that's the one we made with serve. And the rest honestly doesn't matter. And if we did this properly, this thing should fail. The bad thing about doc tests is that they run last, unless you filter for those, which I could have done, but I didn't. Okay, here it is, mock server, received request failed. And it panicked because we have a to-do, so the panic speed not yet implemented, which is good. Now, just for the sake of future speed, I think we can do --doc, and we can also pass the name of the thing. Yeah, so that should run exclusively the one we want. Takes a bit longer because each doc test, if I remember correctly, needs to be compiled and then bound. So linked, actually, probably is the right term. So a bit slower to execute than the other ones. But we got it. And the idea is that at a certain point this thing should pass. So let's add doc test for receive the pass. Nice. So cool. So let's do it as we were doing here. South.0.receive requests. So we follow the same convention that we currently have, and that should fail to compile. Cargo C is a shorthand for cargo check. And it says method not found in a server. Which is true, and that's basically like the ref. It tries the referencing, how do you pronounce that? It tries to dereference the type. Wiremock server doesn't have that method, so fail. In the server doesn't have that method either, but in the server doesn't have any method. So it says in the server it doesn't have that method. If we actually go on wiremock server though, and add that method, receive requests, self returns vector of requests, and these are request type, and that should start to compile. Yep, the test will still fail. No need to run it even, but we're good. Okay, so receive requests. For this to work, we need some kind of internal storage. Otherwise, this is not gonna work in any case. So let's just walk through the way a mock server functions. So start is fairly simple. Starts binds a TCP listener, and then once it bound it, it delegates to start on. Classic. Start on, what does it do? So it creates a one-shot channel using Tokyo. So we get a receiver and a trigger. The trigger is the sender half, the receiver is the receiving half, as the name implies. And the idea is that we use the shutdown, so when this channel gets dropped, it means that the mock server can just shut down. So it's a cleanup mechanism. Then what we create is we create a mock set. A mock set is nothing more than the vector of mocks which have been currently mounted on a mock server. And this is behind a read-write lock, number one, and an ARC pointer. Why is that the case? So we need the ARC pointer because what we're going to do is we're going to pass this mock set to another thread. And that's because we spawn the mock server in its own separate thread. Now we might do, like, if we were not too concerned about being runtime agnostic, we could have used, for example, Tokyo spawn. So we could have spawned the mock server like a task. Then we could have kept the handle and used channels to communicate back and forth. Instead, at least for me, it's very important that wiremock works no matter what runtime you're using. And given that we're doing tests and we're not too concerned about performance, it's perfectly legit to spawn every mock server in its own thread, which means that every thread can use its own runtime. Very simple, like single-threaded runtime. And that's not an issue. Because once again, this is not production code. So to pass something to another thread, we want that to be an ARC. And that's because we want that to be in the new thread, but we also want to keep a handle to that mock set. Because the way it works is we spawn the mock server and then we add additional mocks afterwards. So we need to be able basically to write to this mock set from the current thread, so the thread when we are running the test code. And we also need to be able to read the mock set from the thread where the mock server is actually running. And that's why we use a read-write lock, because usually the way people use the library is they spin up a mock server, they'll set up a bunch of mocks, and then the mock server, like they run the logic, and the mock server will be mostly reacting to requests. So this means that for the setup stage, we always want a write lock, but actually for the serving stage, we often want just a read lock. But I'm actually not sure that's the case anymore because we're keeping track of how often stuff is called. So probably it might make sense to convert this into mutex, but one for another time. So what we're doing, okay, we're spinning up this thread, and in this thread we run the actual server. And the actual run server is fairly simple. So it's using Hyper, which we have here. We build a server from a TCP listener. We pass an executor. Where is the executor coming from? Local exec. What's that? Okay, perfect. That's just to say that it's a single-threaded executor. So that allows us to spawn futures which are not sent, which is convenient. And we serve a single request handler. So an incoming request goes through this. And then we have a graceful shutdown registered. So when these shutdown signals, so when that channel gets dropped, then it means that we can shut everything down. Fairly simple. And the local exec is here, so it's a very quick executor for Hyper that I wrote, or probably copy-pasted from somewhere a while ago. And the handler is, it's easy. So you get the mock set, once again, ARC RW lock pointer to an active mock set. And when a request arrives, what we do is we clone the mock set and then we spawn up this task. What does this task do? Well, it reads the request, so it collects the whole streaming thing. There's a bunch of boring stuff done in here, collecting headers, converting those from HTTP Hyperium to HTTP types. We finally get a request of ours, and then we go to the mock set. Well, yes, actually we need a write lock, so probably I should remove the read write and just use a mutex, but fine. And then we handle the request. Handling the request, what does it do? It iterates through all the mocks that we have. If one of those matches, then we return that response template. If it doesn't, this remains an option. So if we have one, we return the response template, and there's a little bit of functionality for delays. Otherwise, we return not found. Fairly simple. Now, the other thing is, where are we actually keeping track of what matched? I don't remember that. It's another funny thing once you have not worked on something for a while. So something here, I think, is in this matches function. Yes. So if matches request, number of match requests, specification, blah, blah, blah. If it matched, then we increase the number of match requests on the active mock. So we differentiated the type level between two types of things. So there's the mock specification, which is what the mock looks like. It's like, what does it match? What's the response? And all the things that the user set up. And an actual active mock. A mock mounted on a server that's keeping track of a bunch of things. In particular, it's keeping track on the number of requests that arrived to the server that matched the specific mock. There's a positioning set, mostly used for diagnostics, so error messages. So what we want to do, so we want to register the incoming requests. We could also register the responses that we sent out, but let's not do that for the moment. So we want to match the incoming requests. That's something that we should either have at the level of the mock set, potentially, so we can have it here, or if we want, we could actually put that at the level of the server. So what that means is that we could have that here on the bare mock server, which, I mean, wouldn't be a bad idea. We'll follow more or less the same pattern. So we would have that to be behind an ARC pointer, and we would have that to be behind a lock, because we want to write to it from the server and read from it from the main thread. I mean, why not? Okay, so let's get started. So what do we have? Received requests. And that's going to be an ARC. Let's make it a mutex. And we want to talk to mutex, because this stuff is going to be held across our waypoints. And what we want is a simple vec of request. Okay, which is already imported. Cool. Now let's the compiler tell us what we need to change. A bunch of things. Wow, that's more errors than expected. So bare server line 64. Yeah, well, the constructor. Oops. Oh, add missing fields. Arc new. I could use the default. I'm just gonna use constructors for clarity. So one IRC, mutex, dropping a vec, which is good. Okay, and the rest of the stuff was just a little bit of noise. Amazing. So we have these here. Now what we need to do is we need to use it. And the way we use it, it's in the run server. So run server though doesn't have access to that thing. So what we need to do is we need to change this as well. Let's see, how did I call it there? Receive requests? Yes, let's use the same name. Receive requests. So ARC, talking mutex, oops. And then we want, we want a request. One on the same crate, which is good. Okay. So what we could do, basically, is we could do this thing here. So we could receive request dot lock. We'll wait until we get the lock. Oh, yes, that shouldn't be a request, that needs to be a vector of requests. So once I get access to that, what I can do, I can push a value there. Push a value, what value? Here we want our mock request, which should be clonable, yeah. And that's basically it. So record the incoming request. By adding it to the receive request. Stack, yeah, that's a stack. Now, what I don't remember is how this lock behaves in practice. So I don't remember if the lock is dropped at the end of this thing, or if the lock goes out of scope here. So this is a wonderful moment to go and check the documentation. Yeah, it does not block, and you can hold it across await points. Bunch of things. Utex card. Okay, that link. That's because I'm looking at the top here, docs instead of docs.rs. Cool. Lock returns mutex card. As long as you have the, oh, this is the old document. As long as you have this card, you have exclusive access to the underlying T. The lock is automatically released whenever the guard is dropped, at which point lock will not succeed yet again. Will succeed yet again. Okay, where is our guard dropped? Fast. Yeah, I understand. I just want to understand, where does the drop point, does it get inserted on the same line? Like, okay, in this case it's like better safe than sorry. So I am sure that this should not go any farther. I have a feeling that this is not necessary, but we'll keep it as is for now. Okay. Boom. Okay. Bunch of things. What's going on? Let's always start from the first error. Okay, run server requires 4 arguments, and yes, that is true. So this is used here. And from here, what we can do is we can pass it the, well, we need to pass it the receive requests. So that means we need to create it actually up here. So this will be receive request, not clone. No, that's in the wrong order. Like this, okay, and then I would have, I want to use the same down here. And that's good, but yeah, the compiler is not happy because it says, are you using some kind of debugging IntelliJ? Just print lines, no debuggers. I don't generally use the debugger unless it's getting really dark and scary, but hopefully we don't get to that here. So receive requests, the compiler is saying, so you're creating it here, and then you're moving that value inside the spawn thread, so you're passing ownership to the thread, to the closure that you're passing to the spawn function, and then you're using the same value down there because you want to store it inside the struct, which is okay. Now, that's just because the compiler is not smart enough, because in this case I'm cloning it, but of course it's a little bit of ambiguity here. So that reminds me why I did this server mock set with exactly the same reason. So server receive requests, and then we do receive request.clone, and that makes it deadly obvious that these we're passing ownership to the thread, while in this case this one is gonna go there. So that should kind of make the compiler happy, and it does. So what we have now is different ownership failure, and this one is in the mock server. So it says you are capturing another variable, the receive requests, inside of the sync block, and then you're moving out, so you're dropping it. Okay, what do you mean? Okay, it's actually the same thing. So we're doing an async move, and the thing is we need to be able to call this function many times. So every time we receive a request. And for that to be possible, but we need to be able to call these async closures many times. For that to be possible, that should not consume any value from the surrounding environment. And that's why we're doing this same thing here. So we're actually passing a copy of the stuff we want to the closure, and so we can clone multiple times, and that makes sense. So this should make the compiler happy again. Almost happy, because then actually we need to do the same thing twice for the same reason, because we have two nested, if I'm not mistaken, yes, we have two nested closures. So one here and one here. And if it looks like I know what I'm doing, it's just because I've been through this pain before. So I kind of know what to look for. But the first time I got that error, I was fairly puzzled. I said, okay, how do I solve that? But it's good we got it. Okay, so let's recap. We added a received requests vector behind a mutex behind an ARC. We have it both in the server handle, so the one used by the user running the server, and the actual HTTP server, which is serving the incoming requests. And what we're doing now is we're recording the incoming request here every time we receive one. So we grab a lock, we wait exclusive ownership of the lock, now we push a request there, which is good. Now what we need to do, and that kind of is the nudge the compiler is giving us, this is not used. So we're pushing stuff from the server side, but we're not actually using at all the handle we have in the bare mock server, which is a perfect moment to replace this to do. So to change that to do into something that actually does stuff. And that's where it actually makes sense. Okay, let's get there in stages. So we want to do self.receive requests. This thing we need to lock, but the lock is asynchronous, while this function is synchronous. So what we can do is we can basically slap an async there. At this point we have something that the references to the received requests, and we just clone it. Once again, beautiful thing of writing code for testing functionality. Very liberal usage of clone, makes things much easier. Okay. Now, if you remember though, on the received requests we defined on the actual expose server was not asynchronous. That was synchronous. So we need to make this asynchronous and then await. Okay, so this compiles. Now the question is, does this... Oh, I was looking for the doc stuff. Here it is. Cargo test, doc receipt. Does this make the test we wrote pass? Not really. Well, worse than that. Just doesn't compile anymore because now this function is asynchronous. So we need to await it, which can do receive request, mock receive requests, $await. Now it should compile. Should actually succeed. Yes, it does succeed. So we got something working, at least a bare bone version of that working. Which makes this a very good moment to commit. Baseline implementation of receive requests. Thank you for coming, Ethan. We'll catch up soon enough. So, what's the next step? Well, the next step is probably we want to make some more fine-grained assertions on that received request. So we could go for something along the line of, well, we know this is a single element, so we can grab the first request. And then what we can do is we can assert some stuff on it. So we know that this should be a GET request. Actually, don't remember. Yeah, this is using the method from HTTP types. So I can't use a string here. So I want to use method GET, but I need to import it. Yeah, that's the right way. This comment actually is out of assert. So we're using the arrange, act, assert kind of philosophy framework for writing tests. So arrange is you're doing a bunch of stuff before running the test. Act is by you're actually making the action whose consequences you want to test. And assert is by you go and make assertions against the consequences. So we have a method. What else do we want to check? We might want to check. I don't want to check everything, so we're just going to check the URL. Don't remember what URL is. URL is a bunch of stuff. What do we want to check on the URL? I'm actually only interested in the path, if I remember how to find it. Let's say. Should be some method there. Domain, port, socket address, path. Perfect. So let's do it. So path. So the serve client is just calling the server without making anything else. So the path should be just a slash. Well, we'll find out. This is slash. And what else? We could check the body, just out of curiosity. We should be empty. So assert blah 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 is empty. Amazing. So the request we are receiving is the one we expect, and it kind of behaves as we expect. So let's commit that. More assertions on the received request. which is good. Now, how do we want to move forward? We could either flesh out the documentation of this stuff, which is one way, or we could start working on the way to make the recording optional, so to say. Let's finish the documentation here, just because it makes it easier to go back to it later. So let me see what style I was using for docs. Okay. So what does this method do? Return the list, returns a vector with all the requests received by the mock server. Since it was started. Return a vector with all the requests received by the mock server since it started. If no request has been served, it returns an empty vector. It returns an empty vector, which actually makes for a very good thing, very good test that we can add. Sample, no request. So we just go straight into assert. We honestly don't even need this thing here. So it's a range, and now we go straight into assert. And this thing should be 0. And thinking about that again, actually, we don't even need this, right? Like we're just asserting that a certain request was made. We don't care about the response. I always like to have, as much as possible, the minimum amount of details in a test. The reason being that when you go and look at the test, it should be obvious what the test is trying to assert. And the least number of moving parts, the more obvious it is what the important stuff is, and that catches your attention. Before there was a lot of noise, now it's much easier to see, okay, the important thing is that we're making a request. Doesn't matter what the response is, doesn't matter what the status is, doesn't matter that we have a mock mounted, and immediately we can get the received request. Now, just to make sure I didn't break it. Now, 2 tests, because we have 2 tests in the same doc block. And they're both passing, which is good. Do we need all the imports we have? Not anymore, right? Weird. Why did they tell me? Fascinating. Actually, this is not needed. And this is not needed either. So this should be more than enough. And in this case, I actually only need the mock server. Load disk space on file system root. Interesting. That might be because I'm recording this thing, and that is going on the main drive. We'll find out. Okay, still builds, and the tests still compile, which is good. Lovely. So documentation plus no request test plus simplify existing documentation test. Once again, we're not being very precious with commit messages. Otherwise, we'll cherry pick certain lines and not others, and so on and so forth. Cool. So it looks like it works, which is not too bad. So what should we do? Well, let's finish the docs. So we want docs here as well. And that's more or less the same stuff that we have here. It's just to make it easier. kind of crock what's going on. Received by the wiremock server. Since it started, returns an empty vector. We don't test this because we already tested the boundary covering for it, so it's not necessary. It's also not a public function, so just used within the crate. Comments here are more to help people who want to contribute rather than help the user of the crate. So they're for developer purposes. In the meantime, comment, docs comment. Comment, the internal method. Just running the whole test suite, just to see that the new feature didn't break anything. Too soon. Yeah, that's why you should always run all the tests. What have I done? Wow. Okay. What is this? The fuck? Linking failed. And can I get a meaningful error message? Oh, okay. Could that be related to that space warning I got before? I don't see any useful error message, unfortunately, that would help me understand what is going on. Oops, I scrolled too early. Yeah, doesn't tell me much. It's weird though. So it was 13 failed. Just wanna see if it's deterministic. Yeah. Well, I am puzzled. Let me see. So let's just check this. Just to check what's going on. Yeah, so the registration of this thing is going in here. So that might be related to the fact that I don't have enough space anymore. Let's make some cleanup. Okay, let's debug the stream while the stream runs. A little bit of inception. Let's see what happens. Sorry. It was an unplanned maintenance. Not even sure that's the problem, to be honest. But actually, that was the problem. Given that the tests are now passing. I'll probably have to stitch together those two recordings afterwards. Okay, so the tests are passing. It's not too bad. So what I want to do now is actually the first reason I was trying to implement this thing. So I want to see if I can improve the error messages. If you were not here since the beginning or you don't recall, so I started by showing what happens when a mock expectation fails. So let's look at it again. When you get this message. So when a mock server goes out of scope, all the mocks that are mounted go and verify their expectations, assuming they have any, which is not a given. Some people might choose not to set expectations, and then, for example, as Alex was saying in the issue, verify certain things manually because it suits better the way their test is structured, and that's fair. But let's suppose you have expectations that you get a verification failed, And it says expected range of matching incoming request more than 1, number of matched incoming requests 0. Now what I'd like to see is also the list of requests. So the list of requests we actually received. So I'm gonna leave this as is for the moment. Let me look at another one, which is more interesting maybe. Actually, let's write another test. This petition is not satisfied. Incoming request. Terrible naming, but you know, just to get going. We, instead of never calling the mock, we sent a request. That does not match. So the mock is expecting a get request. Well, actually, let's do the opposite, which is easier. Mock is expecting a post request, and we are gonna send a get request. Serve get mock server dot URI. This needs to be borrowed. Await unwrap. Cool. And assertions verified on the top. And this should panic because the request does not match and this expects at least something to match. So if we run that, should be enough. Perfect. So this is panicking, which is what we want. Now let's look at that panic message. Awesome. So you see, it makes no difference whatsoever. We're getting the same panic message here that we were getting here, even though here there was no request at all to the mock server, and in this case we had one request. So if I'm trying to troubleshoot why the test is failing, I'm getting some information, but I'm not actually getting all the information I need, or all the information that I could use to actually understand better what is going wrong. So I guess we need to understand how to make this work. So let's see. First of all, where does the panic message get generated? Let's go from the expose server. So this is the mock server we are using externally. And the way this works is when drop gets invoked. So when the mock server goes out of scope, this is going to call verify. And verify, it's going to call verify on the underlying mock, which is here. And then that is going to iterate over all the mocks and verifying that they've been verified. There's a lot of encapsulation here. And then if everything is happy, then verification outcome success. If something is not as it should be, verification outcome failure. Pretty much. And that's okay. So what we want basically is, okay, if the verification outcome is a failure, then we want to also get the list of incoming requests and print those, right? Now I already see where this is gonna go wrong. Let incoming requests. So those were what? Self.0. Receive requests. Now let's use the same terminology. And what I want to do here, well, yeah, I need to wait it. And then I need to clone The problem here being that I'm calling $await, and this method is not asynchronous. And the reason that method is not asynchronous is because we are calling it in drop. And drop does not allow us to do asynchronous operate, to await asynchronous functions. Okay, which is why I was using a read-write lock, which was not the Tokyo one. Now that everything comes back, right? The dirty hacks that you wrote a while ago, they will come back to you. So this is why in this verify, we need to call the lock on the mock set, and we had used the read-write lock from the standard library instead of the one from Tokyo, because we didn't want to do an await in the drop implementation. Although we shouldn't hold the lock across await points, which is, of course, annoying. Okay. But we also shouldn't try to hide the synchronousness in a way of the operation, because one thing we might want to do down the line is actually support a different type of backend in the mock server. So it should be possible basically to say, I have a mock server here, I have a mock server from a pool, or I have a remote mock server. So this mock server is running, for example, on a machine in a cluster. And all these operations that we're doing, like all this setting up and setting down, is actually happening by HTTP requests, which is fairly useful for a bunch of use cases. And for that to be possible, then like certain things need to be asynchronous. Like this verify should be asynchronous, shouldn't be synchronous. Because in that case, that would be a call to a mock server running somewhere. And so, yeah, we gotta resolve this little situation. One thing I could do, potentially, is just spin up a runtime and block on this thing. What was the syntax to do this stuff? Yeah, new current thread. Thank you. What do I need? Enable all? Maybe. Build. I think everything should be enabled by default. I mean, I don't need I/O and I don't need time. Okay, just to build. Unwrap, and then boom, block on. And then this needs to become an async block. And this needs to return whatever it does. Okay, not sure at all this is the best way forward, but let's see. Okay, receive request. So at this point we have it, so that should make things a little bit easier. And so what we're trying to do then is we're trying to format this error message. So we have verification failed, new line, and all these error messages. And then what we could do, basically, is okay, receive requests, CLI message is a receive request dot into ether, and then we map over those requests. And then we're gonna collect everything into a string. What do? want to do. So the received requests are in order they've been received. So it really would be nice also to print a number. But we can probably wait for that. So let's just print all the received requests, each one on its own line for the time being. So that would be just our select. And then here we have received requests. Then we go another new line. And this becomes received requests, new line, received request message. I don't think this is gonna compile, but it does. And let's see how the test evolves. Okay, that's actually not too bad. Well, to an extent. I would have liked that to be indented, but I think that's worse in life. So what's happening? Received requests, that is correct, and we get HTTP localhost, host something something, user agent Isaac, and that's because it's surf. All the headers, and there's no body. Okay, so that works. So the other thing we could do, so this is already like half of what we want. It's not too bad. How do I indent everything in Rust? So how do I make everything like one tab to the right? Because that's actually what I want here. Indent string. I feel like there's some crate that does this. Indent foobar and then indents everything. Okay. Is this crate used by anybody? Yes, it definitely is. The command line programs to force dynamic output nicely so that it looks good in a terminal. Oh yes, my friend, that's exactly what we need. Getting started. Oh, this also does dropping. Okay. My strings are not known at compile time. Okay. And what dependencies does he have? Stuff that probably already I have. Okay. Okay, text wrap. Let's give you a go. Nice. Docs. And we were looking at this indentation. So text wrap, double double, indent, and then before and after. Okay. So that means that in the expose server, what we want is okay, so we should do things in a slightly different fashion. We want the number of the request, so request number 1, request number 0, and then colon, new line, and the request indented. So I think what I need here is enumerate. So enumerate is going to give me the index. So we got index and the actual request. And what I want to do with that is request number, and that's perfect. Then I go new line. So this is index plus 1, so we don't want them to be 0 indexed. We want to start request 1, request 2, request 3, request 4, which, by the way, is actually coherent with the way they're coming through because there's a lock. So actually the mock server handles almost one request at a time. Oh, there's a choke point on the number of requests. And now what we want here, we want this request, and here that's what we want to do. So we want to get this request, the bug implementation, can code like that. I'm sure there's a better way of doing this, but we're gonna power through. Request, I don't want any prefix, I just want, my prefix needs to be a tab, basically. Okay, so if we go again looking at the test, what does that look like? Oh yes. So that actually starts to look like what we want. Request number 1, get, accept, host, content length, etc. Lovely. What else do we want to do? Okay. So let's do that. Print receive requests. If the expectation verification fails. That's nice. I mean, we're doing a shitload of string allocation here, which we could probably optimize, but we're going to leave it as is for now. You can probably print once, instead of like allocating strings and more strings, but you know, getting it to work first, getting it optimized later, if ever, if necessary. So let's try to sort out this Tokyo thing. So if we're gonna do this dirty thing of like creating a runtime and then blocking, then at that point in time it would actually make more sense to be honest, and so make this function asynchronous, and then like this runtime creation with blocking should be done by the caller who needs to be able to call an asynchronous function in a synchronous context. So what we want, oh no, wait, too much. So basically, verify should become asynchronous, and what we need to do is instead, it's down here. We do this. Block on self.verify. So actually I don't need this wrapping, I can just go self.verify. Now what I don't know, at least by heart, is how this behaves in terms of panicking. So if the panic, because verify is supposed to panic, basically, if things are not working. So if the verification fails, it's supposed to panic, and then the panic makes the test fail. I don't know if this block on is going to propagate the panic. Find out. So verify, this is asynchronous, so none of this is needed anymore. So this becomes just .away.clone. Nice. Which is good. What else do we want? Well, let's see if it compiles. It does. Do the test work. Well, yeah, the test is failing there because of the fact that we commented out the should panic, but it's still panicking fine. So yeah, still working. And then probably what we should be doing is we should make it true that this verify should actually be asynchronous. And what we should be doing is we should be using the right type of lock. So actually this mock set shouldn't be a readw lock from the standard library, but it should have been a lock from Tokyo. And the same is going to be true most likely in one server. Yep. I imagine something is going to start failing because we changed the lock. Yep, of course. Web server line 87. 8087. Yeah, so this is right.await. Line 93. This is right.await. And then we have line 207 expose server. Self.verify, this is asynchronous, so now it needs to be awaited. And then we have a num drop on line 37 of hyper. Yes, this is up once again. Await the lock and then you handle the request. Nice. Let's check stuff is still working. And this is actually a breaking change because verify is a publicly visible function of Novoto. And that means that this will have to be a breaking change. But that's fine because we probably need to change the API anyway to accommodate that builder pattern we were discussing before. So press that. Okay, verify. All cool. Create the list of received requests. Make expectation, verification fails. Make verify asynchronous. And swap standard sync rwlock for Tokyo sync rwlock. Lovely. Which is good. Okay, we have achieved like 99% of what we want. So let's do the remaining 1%. So first of all, let's make that test. So it would be nice to have an assertion on the panic of the message panic, just to know, that it's there. How could I do that? I would have to catch the panic. Let me see. Assert on panic message. Yes, that's what we want. No, not really. Oh, okay, I didn't know about this. It's worth mentioning that you can have a check for the panic's text. Should panic expected, assertion failed. Okay, so let's go and have a look. Should panic rust doc. Where do I find the documentation of should panic though? Is that in the standard library? Yes. Okay. It's the first time I look at this stuff. So which one is the actual proc macro? This looks very internal. Very internal. Okay, I can't find it. Also because I don't know if that is an exact match. Okay, let's try. Let's see what happens. So we want to say this should panic. And should panic, assert, message, rest. I haven't been smart, so I closed that issue on Stack Overflow. Okay, expected equal. So it's expected equal, double quotes. Okay, and now we're gonna have fun figuring out how new lines are interpreted. I'm almost certain this is not gonna work. In fact, panic message, blah, blah, blah. Okay, I need to... Oh, can I probably have a row string literal here? Once again, probably not gonna work. Does it say? Yeah, it's saying that I don't have a tab here. Yeah, it's missing all the /t things. Well, I mean, which is true, they're not there in the first place. So maybe if I add them, it's gonna be happy. It also seems that it's doing a substring match. So it's not looking for an exact match, it's just looking for the fact that our thing is below that. Yeah, but that doesn't work because, of course, oops. A little bit of trial and error. Okay, why do I have a double slash? Probably because I'm using a row string literal, which I shouldn't at this point. Okay. Now this is looking very similar. Where does it break? Oh, okay. So it seems that the order of the headers is non-deterministic. Therefore, I will never be able to match on that. So what I can do, given that it seems that this does a sub-string match, is I can just match up to the route. And that should be okay. Yes. Receive requests are printed as panics if expectations are not verified. Printing as panic message if expectations are not verified. Now actually I would be curious to have a look at this one. So what happens if we don't have any request received? Panic with a received request, colon, empty space. Which is, I mean, it's not the best, but it's also not ideal. So we can probably do something similar to what we did here, and just change the assertion. So instead of saying receive request or printed, we can say no receive request line is printed. Panic message if in panic message if expectations are not verified. So what we want to see is the server did not receive any request. Nice special case, makes it obvious no request was served. And we can do that. So first of all, we should see this fail. First and foremost. Nice, it does. Test checking for panic messages. Okay, now we need to go and do it. So it should be enough to special case this here. So instead of doing this, we can do if receive request dot is empty else. Okay. What's up? Oh yes. Missing a parenthesis. You know when the IDE is not helping, trying to autocomplete too eagerly. Okay, let's go back to the test. We need exactly that message. Server did not receive any request. Oh, what did I do? Wait, something. Yeah. Made a mess. Perfect. Into it's not enough. And that should pass now. Not at all. Yeah, I need to get rid of the semicolon so that actually returns the string value. So this might be a pattern you're not familiar with if you come from a language which doesn't have if as expressions. So each branch of the if else actually returns the last value in the block. So in this case, this branch is returning a string and this branch is returning a string. And basically we're assigning the result of the if else expression to that variable, which is quite neat, makes things a little bit cleaner, so to say. It's not happy. Oh yeah, because we are using a name test. So if you see here, there's a panics if expectation is not satisfied. That happens because we are setting a named here, which is sometimes useful when you have a lot of different mocks and you want friendly names to remember them. But in this case, it's not what we're testing for. So we'll just get rid of it. Okay, so you see we're still printing received requests. The server did not receive any request. And that's because that line is added here. So what we want to do probably is we want to put that forward. Once again, don't do this at all. It's like the amount of string allocation is painful to watch, but it will do for now. Cannot infer time for parameter B, you're right. So this should be collecting into a string. And I can tell you like this. I'm not mistaken. Yes. Okay, now we're having fun. Tokyo cannot start a runtime from within a runtime. This happens because a function like block_on attempted to block the current thread while the thread is being used to drive asynchronous tasks. Nice. Also not nice. This is coming from what test? Oh, from the other test suite. So basically, the test we were trying to do so far is working. So that's great. Now, a thing I have in wiremock, and I developed over the months I've been developing the library, is having tests with different runtimes. Like mixing and matching between Actix, RT, Tokyo, all these other tests, other things stood, just to be like on the lookout, like just to know if by any chance this thing could be could have issues with certain runtimes. And these things do catch bugs, and here we see it. So what's the situation? In that, so let me first of all let me commit that we fix find message for failures where no request was received. So in this drop block, what we're doing is we're creating a new Tokyo runtime. And there's one thing that Tokyo doesn't like is nested runtimes. That definitely doesn't like. And so as long as we were running tests using a sync stud, that was fine because there was no Tokyo runtime. In this case, the test is running on Tokyo. There is a Tokyo runtime. We try to create a new one, and then Tokyo says, whoa, 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 no nested runtimes. How do we fix it? So I think it should be possible right now to get a handle to a runtime. How did that work? What was it? Runtime current? No. Handle current? Yes. So what current does, memory serves me well, is it tries to get the current Tokyo runtime. And if there is none, it's gonna panic, which is not what we want. Because if we use context current, then what we have is our tests work for Tokyo, they don't work for any other runtime. So what we wanna do is we wanna do try current. So what this means is we don't know where we are, but if we are in a Tokyo runtime, then we're gonna first check if there is a running runtime, and in that case, we are going to spawn. Can I block on with that? Let's look at the documentation. Okay. That's very classic, where you think you have a good idea, then you start writing it and you realize probably it wasn't a good idea. Okay. So get a runtime with current. Now let's look at it. I can get a join handle if I spawn the future, but then the join handle needs to be awaited. Doesn't make things any easier. Not good. Spawn blocking, same problem. Like I need something like block on. Which of course it's not possible. Course doesn't work because you can't block the current thread because the runtime is already running. How can I make this happen? Is that? No, that doesn't work for the same reason. So one thing I was thinking you could use is a local set. Which, I mean, I don't know the finer details because I haven't been playing with these things for a while. But the idea is that the local set is some kind of local runtime that is not going to be multi-threaded, so it runs on a single thread. And that local runtime, then you can block on basically until it's completed. But to call block on a local set, you need an actual reference to a runtime, which is not what we have. Like what we have is a reference to a handle, which I don't think we can use to do much. So with a handle we can spawn, but we can't block. Catch-22 situation here, which remembers me why I was trying to avoid having to call an asynchronous function in the drop block. I could cheat and use the futures executor, but I don't think that's probably not gonna work because the logs are spawned on the Tokyo runtime. Interesting. Asynchronous functions in drop Rust. Let's see if Google has something to support us. You don't have async drop, unfortunately. I know that. Yep, that's what I was about to use. Tokyo main doesn't work. I can create a new runtime. I don't want to use a sync stud either. That doesn't make a lot of sense. Let's see. I mean, I have the futures create here, although I don't think I'm bringing in the executor feature. Let's do some more research first. In particular, looking at Tokyo. Okay, printing future, that's all very nice. Get some wakers. Yeah, I guess basically what we want is spinning this thing up somewhere else in a thread, waiting for the thread to finish, and then being done. Oh, not interesting. Not interesting. Not interesting. And this was stuff from before. Okay. Let's cheat our way out for the time being. So this was the elegant solution. Oh, sorry, no. Let's do the unelegant solution. Use this. Let's see if that compiles first and foremost. I use import. Yeah, asynchronous destructors would make certain things certainly easier. So the test actually is passed. All the ones that were failing before. Architects Tokyo, async studio, all the tests are passing. Which is good. Now, actually curious to see. Run executor, what does this do? Set up and run a basic single-threaded spawner loop, invoking F on each turn. Okay, while exiting the area, I fully understand. But it's probably something I need to dig into later. Okay, so somehow, some way, we got that to work. Not amazing, but fine. Fix but it does. What else is missing? So we're recording incoming requests. Good. We are displaying a much better error message on failure. Amazing. We've done the documentation piece. That's also good. So the only thing that is actually missing at this point in time is making it configurable. So making it so that somebody can spin up a mock server without necessarily wanting to save all the incoming requests. And the reason for that, we said it before, is people might run very long-lived mock servers. So for example, as we discussed earlier, a remote mock server running there continuously. And they might not want to record all the requests, especially because if they have several, if they have a lot of traffic, that's going to slow down and kill the performance of the mock server quite dramatically. Which means we want to do something different. What can we do? We can... So we need a builder function of some kind for the mock server. So let's go back to the actual expose server. Because the moment we just have start and start on. And start on was okay, because it was just a quick way to get some configurability. So when you have a single parameter, that works. Now that we want to configure multiple things, this doesn't work anymore. So what we can do is we can add a builder method, basically. A function builder, and that's going to return some kind of mock server builder. Oops. And that builder will eventually give us a mock server. And what this means is that we need to have some kind of private constructor that can do what we want. Most likely, if you are configuring the mock server, that means we can put that into the pool. Because the pool needs to be a pool of objects using the same configuration. So if you're running customized things, which was already the case for start on. Like if you're using start on, you're not getting a pool server. So that's fine. Let's create a mock server builder. So mock builder. And now we want to do pub use builder mock server builder. Struct mock server builder. It's gonna have some stuff inside. We don't know what yet. And we need to be able to create one. So we want int mock server builder Sometimes you want people, like certain crates have, of course we need the builder type to be public. Certain crates also have the new method on the builder type public. I generally don't like that. I prefer for it to be only one way to create a builder, and that's usually from the type that you want to build. So the pattern is mock server, colon builder, instead of having two different ways of doing the same thing, which is somewhat confusing. Pub crate function. So we make this only visible within the crate. Well, actually, for the purpose of this stuff, we only need it really pub super, so only visible in the mock server module. So this is gonna be just self. There's no fields, so that's gonna work. And then in here we can import the type. Yep. And that's good. So this is gonna be mock server builder new, which is okay. So what do we want on the builder itself? So on the actual builder, what can we customize? So we already know at this point in time that the thing you can customize is the port that the server is going to run on. So that's going to be something along the lines of listener. Standard TCP listener, and that's an option that we can use. So you can specify one or not. And then the other configuration value that we want is recording request. So record incoming requests. And by default, so this is going to be a boolean. And so when we start, what do we have? You don't have a listener, and the incoming requests, you're not recording them. You are recording them actually, sorry. So that's the default value. And then we're just going to provide a bunch of methods to set those values. So that's going to be a pub fun listener, and you take self by value, and you have TCP listener, and you return self. Mute self.listener. This is like classic builder pattern in Rust. And then you have record incoming requests. Okay, what's the best way for the name of the function? Record incoming request or do not record incoming requests? So probably we want something like this. Do not record. This is classic name problem. How do we call this function? Do not record incoming requests. There's one way you could do it. As like request recording. And then you could have an enum here saying enable disabled. And that's probably what we're gonna do. No, actually, that's too complicated. Let's just do this. Disable request recording. So the default is true, then you have a disable method to make it false. Record incoming requests. False. And then you're gonna have your build method that consumes self and returns you a mock server. Import, And now we need a function to build a mock server. How do we do that? We need to have a path on new server. New self. And this actually needs to be private to the crate. And as input, we're gonna get an inner server. And then this is gonna be self. Oh, yeah, no. Self server. And that's fine. So what we actually want is a builder for the bare mock server, which at the moment is as a start on. So we can probably just start. Start, and this takes a listener, and then we have request recording, and in this case we're gonna be doing pub super request recording. So I don't want to have an additional enum in the public API, because that in this case probably doesn't deliver a lot of value, but for the internal API it actually makes things more readable than just getting a function where you pass a boolean which is true or false, but then you don't know is the name of the parameter enable request recording or disable request recording. So easier to just have a little enumeration. Okay, so request recording. Start listener request recording, that's good. Again, so yeah, that's the usual problem we were having before. So that's small issues when you do things for the first time. So the instance of wiremock server, listening and specified TP listener, request recording is either enabled or request recording is enabled. Well, that's obvious, kind of doesn't need to be documented. So this probably should go on the builder. Each instance of mock server is by default running on an unknown port. We need listener. Mock server builder. Listener. You can choose to start the mock server instance on a specific port you have already bound. Okay, so let's start adding some docs. By default, mock server will record all incoming requests to display 4 meaningful error messages should when your expectations are not verified. Mock server. These can sometimes be undesirable. Server high volume traffic. Can disable fast recording using mock server builder. Disable request recording. Cool. Finalize the builder and get to get an instance of a mock server. And in case we actually want to link, so we're gonna wrap in square brackets. Same here. Builder or a mock server. A builder providing a Fluent API to assemble a mock server. Step by step. Use mock server builder to get started. So that's why it's easier to have a single method, and you always refer them to the same stuff. Okay, so in this case, what we will build, as we just saw, is where mock server. This now has a single method called start. What we do is TCP listener bind. No, sorry. Oops. So one at a time. So listener. If they've given us one, self.listener, that's the one we use. Otherwise, we go and get one ourselves. Find 107.1. Port 0. So port 0 is going to give us a random port available in the operating system. And I think this thing is failed to acquire an OS port. And that's fine. Failed to bind an OS port for the mock server. Mock server. Okay, the other thing is recording incoming requests. Recording. And in this case, what we do is if recording incoming requests, self-dot, so this is going to be recording, request recording enabled, otherwise request recording disabled. And then we just put listener recording. I don't remember if start is a synchronous or an asynchronous method. Oh yeah, we have a conflict here. So this needs to go. Now we have a single start. And it's asynchronous. So this needs to be asynchronous, this needs to be awaited. And this thing returns a wiremock server, which we can then wrap. So we can do mock server new, which is the stuff we added before, and then we can do inner server wiremock server, I think. But then that's not computing, and this is because this enum is not public within the module. So if I do this, I can import it, and I think that's basically it, isn't it? Let me see. Does it compile? because what's going on? So in the exposed server situation, we had start on. So this one we need to move as documentation here. So we want to have the example here as well, but this is going to look different, so we're going to change that later. But the idea is that this disappears. These are server pool. And what do we have? Let me see. So what we're missing is mock server pool line 51. Yeah. So how does the pool create a new mock server? Well, what we can do, we want the pool to have mock server with default configuration. So we go mock server builder dot build. All servers in the pool use that default configuration. The only issue we have with that is that that returns mock server, not a bare mock server. So probably we need to have a little bit of an escape hatch for our internal API. So we're going to have a build bare. This gives us an instance of a bare mock server. Which is fine. And then build is just going to be using the other one. So that would be self.build bare. So we're not duplicating logic, which is fine, but we have what we need to use it in the pool. Almost. Yeah, so it's Cargo is complaining that start has create visibility, but start uses request recording, which has super visibility, which is actually the one we want. So we can, what is it? Start on the bare server. So we can change this to be Capsula. Okay, perfect. So in the exposed server, we're going to use the import. Fine. And then the other thing we're missing is request recording is actually not used. So good moment to document. So introduce mock server builder. And then we need to start using this request recording, which we have here. And the idea is that, of course, we should pass that somehow to the run server. So what we could do is probably the simplest thing is receive request instead of being an ARC mutex spec request, because we need to distinguish between the scenario I have received no requests and I was not recording incoming requests. So what we can do there is we can make this an option. So this needs to be wrapped. So here is if request recording, okay, match request recording. And then if request recording is enabled, we are doing this. So the same way before, just wrapped in sum. And if request recording is disabled, we're just going to go none. and this works. Then run server, this needs to become an option. And that's fine. And this become if let sum. So if we have some received requests, so we're keeping track of those. That also allow us to get rid of this thing. Oops, one line too many. If let sum received request equal received request. If request recording is enabled. To record incoming request by adding it to the receive request stack. Sounds good to me. Does it sound good to Cargo? Not really. Where server line 114. Where server line 114. Oh yeah, of course. So return a vector with all the requests received by the wiremock server since it started. If no request has been served, it returns an empty vector. Okay. In this case, what do we do? Given that now request recording is optional, it probably would be semantically correct to return an option. Pretty much. And yeah, I mean, we're just gonna return an option. Or we could panic. That's the other option. But that would be a little bit too heavy-handed. If request recording was disabled, it returns none. So this basically becomes I could do this with map, but then I need to call an asynchronous function that makes it awkward. So we do like this. Nope. If let. I'm getting a bit tired. Receive requests. So this goes here. Wrapped in some. Otherwise we return none. And this doesn't work. Yeah, I want you to move it. It's enough to just get a reference. Okay. It's getting better. The compiler is guiding us because there was, of course, now this returns an option. All the places where we were calling it need to account for the fact that it might not be there. And that is the expose server on line 195. It receives requests, right? This function is getting uglier and uglier, but so if let sum receive requests and that is self.o.receive requests await. Okay. Then we're gonna do this. Yep. Okay, we could actually just do the whole thing here. What do we return in the other case? So what do we print if request recording was disabled? We can probably just print that request recording was disabled. Enable it. request recording on the mock server to get to print requests to get the list of incoming requests as part of the client message. Okay, I need to remove that. Okay, ugly, very ugly, yet works for now, at least. Probably don't need this string annotation. Indeed. Okay, so that's fine. Almost. 326. 326 receive request option. And that should compile. And then here, if request recording has been disabled using mock server builder, disable recording, it returns now. And we can add another example here, which is also going to serve as a test. So we have mock server builder, and this is going to do disable request recording dot build. Wait. Okay, and then receive request, and this is gonna be assert is none. And in this case, instead we can drop it. Does that work? Yes. Do the test work? Okay, something not working. Yes, that's the test we copied, so that's fine. So example, request recording disabled. And that is actually what we want to bring in the builder. So the one that is failing at the moment is this one, but I also want to add a small example here, just to show what that looks like. And then we can probably use this one to do the same. So listener, and yes, instead here we do listener. So and this becomes assert. So actually this is out. This is assert. Let's try. That's a nice thing also about doc tests. They serve as documentation, but for a crate this simple as wiremock, you can actually have most of your tests as doc tests, and they cover basically the whole API. Okay, nice. So everything is passing. It does. Now what we want to do, just one thing I noticed, is that we're using start as initializer for the mock server. So build is a little bit confusing, as in like I built it, but is it running? So I'm gonna change this to start. Analyze the builder and launch the mock server instance. Now, I use the automatic refactoring from IntelliJ, but I'm not sure that covers documentation tests. So let's see if they still compile. Yes. It seems it also changed the doc test names, which is quite cool, actually. Okay, Kako format. Is everything documented? Seems it is. Okay. Mock builder build to mock builder start. Okay, time to look at the docs. Okay, first of all, there's a few things that we need to change. Expose server, this trunk mock server builder has no field or associated item name disable recording. Is that true? Disable request recording. Okay, so let's go fix that. Yes. I can actually remove open. Just want to check. Okay. This item is private. What? No, it isn't. Oh, okay. Is it because it thinks it's the... Okay. Why does it think that the item is private? Okay, let's look at the docs for a sec. Mock... Oh, because I'm not exporting the mock server builder. So I'm exporting it from here, but I'm not exporting it from here. Okay, let's try again. Perfect, so that is fixed, and then we have an actual unrelated error that was here that I never fixed. Source matchers 125. 125, any matcher, and that is any matcher new doesn't exist, so that's a shorthand for any matcher. Awesome. Fix in trunk documents. Okay, so let's actually look at the logs. Those other tabs. The mock builder is here. That's nice. The mock server builder, sorry, as a link to the mock server. So if you don't know where you're coming from, that's gonna go around. Actually, that just makes me notice that this mock is not a link. So let's go fix that. We should also quote the fact that now there is a builder. you can also mock server builder to configure to set custom configuration. You can use mock server builder if you need to specify custom configuration. A specific port or disable the request recording. Okay, and this should be a link as well. And this should be a link as well. Cool, this is all good, this should be a link. Run. Okay, no, not yet. So this is a link now, and this is a mock to the same one, so that's fine. So if I go on the mock server, it's an HTTP instance, blah blah blah. You can use mock server builder if you need to specify custom configuration, run on a specific port, or disable request recording. And now we have the builder function, which doesn't have documentation yet. Let's add some. You use mock server builder if you need to specify custom configuration. Otherwise, if this is not your case, use mock server start launcher server. No, that's fine. So let's build the docs. Awesome. You can use mock server builder if you need to specify custom configuration, run on a specific port, or disable request recording. If this is not your case, I use mock server start. That links underneath. That's an example. A bunch of things. I need to do a pass of adding more links to these docs. Yep. Okay, then once I have a mock server, let me see the request received. Thanks. Then a vector with all the requests received by the mock server since it started. If no request has been served, it returns an empty vector. Okay. Looks good. Okay. What else do we need to do? We had a few. Oh, I closed that. A few notes we took at the beginning on an MD file, which was how does the recording interact with mock server reset? So reset is explicitly about expectations. I don't know actually. No, it's actually better if it deletes all the recording. And the reason why that is the case is also because reset is used in the, what is it? It is used here when we put it back into the pool. Now, you might argue, no, yeah. The field configuration has recording and pool is default configuration. So if we don't, then you're gonna have all sorts of things popping up again. So let's try a quick test for that. it also resets request recording. It also resets. But sets request recording is not the thing. It also deletes all recorded requests. Okay. I can add some link on the file. Spend some time doing this boring thing afterwards. And then I can go down here. Go to request and reset. Mock server. So we make a request. Once again, we don't care about the status. We set the server, and we go here. Mock server receive request unwrap. That actually is asynchronous. Reset. So assert equal. It's actually another. We have one request. Got it. Incoming request. So assert that this is not empty. And let's see. Okay. I see a failed, probably failed to compile. No, actually, that's correct. We brought the test before running the implementation, so that should fail. Document the expected interaction between reset and recorded request. And then we need to go in reset. So we also go receive requests, let some. $8, and this needs to become, so this needs to be mutable. This becomes a new vec. Is there a way to delete a vec? Rust empty vec. Just out of curiosity. Oh, there's a clear method. Yes. Because in this way we keep the allocated capacity, which totally unnecessary, relevant in this case, but just because. Does it compile? Not really. Borrowed here. Yeah, I want unbeatable borrow, which I can't do. Which is good. I don't need unbeatable borrow, just need a normal borrow. Did I move there? Remove the mute. Yeah, it's fine. Okay, that works. Yeah, mutex in the internal mutability always gets me a bit. So this should work now. So if we had forget to deal with that, we would have released the bulky version because the pool server would have not reset the requests, and then the messages would have been wrong as soon as one of the server was recycled within the pool. So good catch in this case. Okay, seems that works. What's that? Quite a few commits. So this one we did. We implemented the way to disable it, and record and replay, we only pull the server if it has default configuration. So we addressed everything that we had in our notes. So I think it's safe to say that we're done. So what we're gonna do is we're gonna push everything up and just check very quickly that our CI is happy. And record functionality to mock server. And that fix closes the open issue, so the one we started with, store receive requests. So assuming that it works, we should be able to move forward. Yeah, I should kind of fix my GitHub Actions setup. It runs twice when I open a pull request, which means it's fine, but also not ideal. Find it always useful to have a second quick look from the PR view, just like to spot if there is something obviously wrong. So this makes it a breaking change, pretty much. Like removing this function, making this function asynchronous, they're both breaking changes. So we won't be able to release the library unless we bump the version, pretty much. So probably a thing I should do as well as part of the APR is make this 050 alpha. Bump the minor version. Oops. I won't release straight away. There were a few other breaking changes I wanted to make, so I'll wait probably later to cut the release, but we're basically there, which is cool. So tests are running fine. Cargo edit is running fine, which doesn't really matter because it's a library. So it's running fine on our cargo lock, which is okay. Clippy is the one I'm interested in too. Okay, Clippy is green as well. Security audit green, and then I mean it's running again. That's good. front S. Since a bit. Oh, still compiling. Yeah, that's fine. But also think of running things twice and you get these issues. I could just merge, but I would be a good boy and wait for CI to go green. At least on this commit. Okay, it's almost done compiling. Nice. We actually could use to compute the code coverage on this project, which I haven't done in a while. Although it should come out of this job as well. But cargo turboline is fairly slow. So running it locally should be faster than running it in CI. At least faster than the default runner you get on GitHub Actions. Or maybe not, let's see. This one had 3 minutes of head start. 62%. Is that the final coverage? Yep. Oh, it's mostly missing lines on matchers, which I could fix. And some lines in expose server. Cool, oh green. As we say, ship it. Nice. And this closes the work we wanted to do today. It's been fun. Probably try this streaming thing again. But I guess that's everything for tonight. Thank you for watching and see you soon.